What's up everyone, my name is Andrew Fung. So today I'll be showing you how you can calculate and plot the best fit line, also known as the linear regression of a dataset, using Python. Now there's actually two ways to do that, and the first way is to make a custom functions that calculates the slope and the y-intercept of the list and plot the regression line out of that. And the second method is to use SciKit-Learn library, which just needs 4 lines of code. And I'll be showing you both methods. And for this tutorial, we'll be using the weight and height dataset provided by Kaggle. I'll put the link of this dataset inside the description box, and if you have successfully downloaded this data, then you will see there will be 500 entries, data entries for males and 500 for female. And the whole dataset will be regarding their weight and height. So the mission today is to find out the relationship between the height and weight, and possibly to predict the average male height and the weight. So without further ado, let's get started. So the first thing you should do is to import pandas as PD, obviously. And to load in the data frame, we can do data frame equals pandas.read CSV. And the dataset's name is weight height.csv. So let's see. Okay, we have a dataset with 1000 rows, and I believe it's 5000 for male and 5000 for female. So let's only extract the data frame for just male, and we do that by a data frame. We specify the gender and then make it equals to male. Make sure it's a string, and then we can just extract the first 200 data so that there won't be too much of a overlapping of data points. And let's see. Okay, we have 200 rows. So now we should do some data cleaning. And what I mean by data cleaning is to convert the inches. So now the data set, the height is in inches and the weight is in pounds. So let's convert the height into centimeters and weight into kilograms. Male data frame, and extract the height and set the height equals to the same thing, divide the same value, and then apply the calculations. Lambda x equals to x times 2.54, which 1 inch equals 2.54 cm. And we do the same thing for weight, except here 1 pound equals 0.45 kilograms. So we calculate this value, and then let's see male data frame. Okay, so now it's converted into so now the data frame is converted into centimeters and kilograms. Okay, and now we have to convert the height and weight into list. So we can do that by height list equals male data frame dot height, and then use the method to list. So it basically takes in columns and then turn the whole column into list. And same thing goes to weight. And now we have to convert the list into numpy list to be able to use the SciKit-Learn library later on, and also to plot the whole thing. We have to convert the whole list, the two lists, into numpy list. So let's do that by x equals numpy.array, and it takes in the list, which is the height list, and then set the data type to numpy.float 64. Same thing for the weight. This time is the weight list, and same thing. And also make sure to import numpy as np. So now we can quickly visualize the result using the plot matplotlib. So let's import matplotlib.pyplot as plot, and also from matplotlib import style. Okay, so we can visualize it here. We use the style seaborn. This is to enhance the contrast between the data points in the background. And then let's do plot.scatter. Plot in the x and y's. Label it as the data points. Let's do alpha, which determines the opacity of the points, and also the color to be green, and the size to be 675. And then we can plot.show. So now you can see the weight and height distribution here. So it's basically if we have to plot a line, a best fit line to summarize this data, I think it's here. The line is roughly here. But using our human estimation is not that accurate, so let's make sure we do that using the mathematical calculations. So we have two methods to calculate. So the first method is to use our own best fit line function, which I won't go into the details for the mathematical calculations, but it's basically calculating the slope and the y-intercept from the list. And the second method is using the Python's built-in SciKit-Learn libraries and using the linear regression model. So let's first take care of the first method. So now we have to make a function called the best fit line. So let's from statistics import mean, which we'll be using later. So let's define a function called best fit line that will take in two lists, which is the x and the y's. And here is the height list and the weight list. So the slope, first we need to calculate the slope, which is the mean of x, the list of x, times the mean of y list, and then minus the mean of x list and the y list. And then we divide the whole result by the mean of x times the mean of x, and then minus the mean of x times x. So that will be our slope. And for the y-intercept, it will simply be mean of y's, the list of y's, and minus the slope times the mean of x. So this function will return both the slope and the y-intercept. Okay, so let's use this function best fit line. We can first, in the first method, let's do slope and y-intercept equals this function, and we take in the x and the y's. Okay, so we now have the slope and the y-intercept of this, the male height and weight. So let's get the regression line. The regression line will be regression line equals, it's a list of y, so let's do slope times x and then plus the y-intercept that we just calculated for x in x. So basically we do a for loop here for the x inside the list. So for all the height inside the list, the height list, then we calculate the weight using the slope and the intercept that comes from the best fit line calculation function. Okay, so let's plot it out to see if it works. So let's do plot.plot. We do x and the regression line, and the label we set it to the best fit line, or line of the best fit. Make it orange so that it's easier to see, and also make the line width to be 4. Let's see. So there we go, we have the line of best fit. So it basically tells us the relationship between the height and the weight. So if a person is of height 165 centimeters, then his weight should be roughly 75 kg. That's a fair assumption. And so let's do some predictions. Let's say the average male in US is 5'9". So in centimeters is 175.26. And let's predict his weight using the functions that we just calculated, which is the slope times the height, and then plus the calculations, which is the y-intercept. And let's visualize this using plot.scatter. We have to make sure it's plotted before the linear regression line. Let's do x average male height and average male weight, and let's do the label equals average man prediction, something like that, and the color to be red so that we can see it, and the size to be slightly larger than the normal data points. Let's also add some customization on the plots. The title will be height and weight linear regression. The X label will be weight. Wait, the X label should be height in centimeters, and the Y label will be weight in kilograms. And let's also plot out the legend so that we can see what the points and the line is about. So let's see. So we have the nice looking plot. So we can see if the average male height is 5'9", which is roughly 175 centimeters, and his height will be roughly 84, I guess, 84 kilograms. We can also print out the prediction here. Average male weight. So it's 84.8 kilograms. So that's our prediction. So that is that concludes method 1, which is using our own calculations and functions. So let's comment this out. And now we do the second method here. And the second method is to use Python's SciKit-Learn library. So the first thing we should do is to make sure we import the packages from SciKit-Learn. So from SciKit-Learn, sklearn, import linear model. So for the second method, the first thing you should do is to create a linear regression object. Let's make it a height, set it to height weight equals to linear model dot linear regression. And then we train the model using the training sets, which is the X and Y's, the height list and the weight list. So we can do that by height weight dot fit data. So for the X and Y's, make sure that for X you have to reshape it using this here to make sure that it is an array, and for the Y you don't have to make any changes. And for getting the regression line, let's do regression line equals height weight dot predict, and then predict using the x's. Let's see how it goes. So let's comment the average male line out. Height weight is not defined. I think it's a typo. Yeah, it's a typo. So we get the same result for the first from the first method as well. So we have the regression line and all the data points. And to make predictions is essentially the same for this first method. And let's switch things up. Let's do KSI's height equals he claims to be 6 foot, but he's 5'11", so it's 180 centimeters, I guess. And let's predict his weight. And in this case, it's slightly complicated. We have to get the model's linear regression object's name, and then dot predict. So we fit in the numpy array here, which is his height. And then we get the first result, which is the predicted weight of KSI. So let's comment this out first, and let's print KSI's weight. Hopefully JJ won't kill me. It's 89 kilograms. Okay. So for his height, his weight should be supposedly 89 kilograms. So let's visualize it here. And in this case, we change the height to be KSI's height. And his weight here, change it to KSI's weight. So other things stays the same. I guess the label, we can change it to KSI's as well. Prediction. Okay, so here is supposedly 89 kilograms, but I doubt it. Okay, and so now that concludes the tutorial for the linear regression and the line of best fit example. So I hope you get a rough idea on how you can do linear regression with. After this video, I hope you have a better understanding of how you can do simple linear regression model on the dataset, and I've shown you the functions that I created and also the SciKit-Learn library. And obviously the SciKit-Learn library provided by Python is obviously easier to use, and you only need here 3 lines of code to make the linear regression model works. And for plotting, you just need some basic customizations and styling to make it look decent. I also do recommend you to try both methods to enhance your understanding on Python. And as you can see, it's very easy to create a linear regression nowadays. And I've listed the datasets from Kaggle in the description box, so feel free to try it out yourself. And if there are any questions, thoughts, or doubts, then please leave it in the comment section. All the source code will be listed in the description, and you can feel free to check out my GitHub as well. So that's it for me. Thank you guys for watching, and see you in the next video. Bye guys.